Hello and welcome to another episode of Let's Make an Apple Catcher game in Python and Raylib. And as you may already know from the previous part, we've done the basic window setup, and like so. Here we have our basic background and our window with the title bar and everything. That's all good and great, but it wouldn't make for a great game yet. So the next thing we want to do is create the player. We begin with a separate player, a new player class, call it player. Also here in the constructor, the init method, self. We can think about certain attributes we need for our player class. That would be like the player image, or more accurately, the texture. Let's plug it in, the texture. Then we also need a position where we place it, and probably also a speed. So by plugging these into the constructor, we make it a bit more customizable for us when we create a player instance. So first let's capture it in the player attributes. Self.texture equals texture. Self.position equals position. As well as self.speed is equal to speed. So now we got them into our player. Next, what we also probably need is a direction for our input. Self.direction is equal to vector2. So if you're familiar with vectors, vectors could be both points in space, but also arrows or values on the x and y coordinate grid that basically point in a certain direction. So this is very useful for our movement code. And yes, we also need to define an update method. Self for now, pass, as well as a draw method, which will take care of drawing the texture to the screen. We could already define it using one of Raylib's functions, draw texture v. So we simply plug in self.texture. Also self.position. So the little v in here stands for vector and is specialized for the use with vectors as the positional data. Makes it really neat and easy instead of plugging in the separate vector components. So we can simply package it completely in the vector and place it in here. Anyways, now that we have that, we need the player image to load, or the player texture to be precise. So let's make a temporary variable in here. Player texture is equal to load texture. And then we have to use our os.join method to navigate into the folder over here. That's our basket PNG. Let's take a look. That's about it, right? It may be a bit large, I guess, but we're gonna scale it down a bit later. Wait a second. First we gotta load it. Navigate to assets, images, and then basket.png. And now that we have our basic player skeleton class Let's create an instance and make it an attribute of the game class. Self.playerBasket equals player, and then we plug in the player texture, give it a position, let's say, let's give it screen width. Oh, wait a sec. Self.screenWidth divided by 2. Give it an arbitrary value first. Wait a second. Screen width. Sorry. It's a vector 2. So the position has to be a vector 2. Therefore, we'll plug it in here. Self.screenWidth divided by 2. Self.screenHeight times later. Also in the center. And now we just pick an arbitrary value, let's say 5. It's not really important right now, because we just want to display the player basket on the screen at first. Good. That looks pretty much correct. Now we go into the draw method of our game class, and here beneath the background we simply call our player basket, or more precisely call the draw function method, and that should actually do it. If everything went well, we'll see it. I forgot something. Correct. We also have to add the color tint. In this case, I'm going with the original color values of the texture, so it's gonna be white. But we don't want to modify it. And ta-da! Here's the raw image, unscaled image, or texture. I always get that. I'm sorry. Good. Basically that's it. Now we have to scale it down a bit in order for us to be useful in the game. So let's go with the most simple version of it. We simply get the player texture dot width and divide the width by 2. See? Player texture dot height divided by 2. Let's take a look. An integer is required, so we need integer division in here. And ta-da! Here we go. Alright. The positioning is still a bit off. Let's put it a little bit lower and a little bit more to the left. So we can say we put it a little bit centered on the x-axis. So it's going to be minus player texture dot width divided by 2. I think it doesn't matter if it is float in here because it's a vector. And the same thing, okay, screen height, let's put it at times 0.85, the screen height. Okay, that's pretty much at the bottom here, and as well centered. So this already looks very useful to us. Now we have to figure out how to move that thing. For that we have the input methods. We could do something like this. We go back into the player class, into the update method. That's where all the movement action takes place. And we have to grab the user input. So let's just go with the command control scheme WSAD, or better A and D only, because in this particular game there's no point in moving the basket up or down. We're pretty much transfixed at the bottom, so we only move left or right. A and D will just do. Yeah, we'll just do. So we start with an if statement. If is key pressed. So this Raylib function detects whether a key is pressed and held. And I'm sorry. Pressed once. Not exactly what we want. Is key down. I oftentimes mix this up too. So we need is key down. And now we need a key constant, starting with key A. So A is going to be our left key. And if that happens, if we press the left key, we want to go left. So our direction value, self.direction.x, has to be set to -1, right? Elif is key down, key D. Then we want to move to the right. Self.direction.x is going to be +1. A little typo in here. Good. Of course, we have to update the position. So self.position.x plus equal self.speed times the direction we modify with each key press. Self.direction. Now, this should already be quite functional, as bare bone as it is. Let's see. I see. Somewhere. Ah, okay, here. I forgot the colon at the if statement. No. Yeah. And else self.direction.x is going to be 0. So in order to reset it, to 0 whenever we let go of the button. Good. Now that we have the basics set up in here, inside the player class, we can try it out. But of course nothing is going to happen if I hit the keys now. That is because we did not call the player update method inside the game update method. So let's do it right now. Self.playerBasket.update. Little mistake. I have to multiply it with the x component of direction. And now we are getting something. Okay, now basic movement is possible. And in here we can of course adjust the speed. Let's double it, make it 10. Yeah, feels a little bit more responsive. However, when we do it this way, we'll run into certain issues. For example, if for some reason the frame rate drops down from our 60, which could actually happen in more complex games, not as much in little games like this one, but the more graphical and complexity you have in your game, the more horsepower you need for it to function properly. So the frame rate may dip down to, let's say, from 60 to 30, cutting it in half. And what then happens is this. It slows down dramatically. We need double the time to get the same distance traveled, which is really bad. So in order to counteract that, we need a concept called delta time. And delta time is basically the time measurement between the page flipping of 2 frames. So in order to implement that, we go back into our game update method and create a new variable called delta time. So delta standing for the change in time, normally in mathematics like represented by a little triangle. And we need this particular method, get frame time. So this get frame time method or function measures the time between 2 frames, normally in milliseconds. Here in the Raylib library, it's going to be seconds, so a fraction of a second. Let's print it actually out in order to see what it gives us. Yeah, down here. At 30 FPS it gives us about 0.033 something seconds. And at a frame rate of, let's say, 60, let's put it back to 60. We'll have 0.16, so 16 milliseconds for each page flip. Okay, that's great. But how are we gonna use it in order to keep our movement distance constant, no matter the frame rate? Yeah, very easy. We simply pass it into our respective update method from the player class, delta time, as an argument in here, and multiply it with our position update. So self.speed times self.direction.x times delta time. Also, not to forget it down here, where we have our game update method. Self-to-player basket update. Alright, we pass it in here. Good. Now let's do it. And oh, you will notice something, because we have fractions. The ordinary speed the speed per frame doesn't work anymore properly, because now we have not 10 pixels per frame, but 10 pixels per second, so the movement is really slow. In order to account for that, we simply give it a higher value, which is also very intuitive because, you know, the screen is about 1600 pixels in width, and we can easily adjust for it. Let's say I want to have it about 500 pixels per second. So it will take about 3 seconds across. Let's make it, I think a little bit higher wouldn't hurt. Give it 600. We can adjust it as we like. So. Okay. You see, and if we reduce it to 30, it's going to run a bit choppier because we don't have the smooth frame rate of 60 anymore. However, the travel distance is just, yeah, we travel at it in the same time. Good. Oh, by the way, another useful function you may use for debugging or checking the performance of your game, whatever, is draw FPS. And then you can define its position, for example, in the top left corner, 1010. Wait a second. Wrong. I have to put it into the draw method. Here we go. Still nothing. There we go. Okay. Yeah, it's very much dependent on the resolution of the screen we chose. And you can see here those little letters, 30 FPS. And now if I switch it back to 60, here we go. Good. Anyway, it is an optional tool. So, one more thing. You might notice is that we can actually go off screen with our Apple basket. In order to prevent that, we have to put another check in here. So, another positional check. If self.position.x is, for example, less than 0, our left side on the screen, then we want to set this position to exactly 0. Let's try it out. Self.position.x is going to be 0. Good. Now for the right side. elif self.position.x is greater than get screen width. This is another very useful function in Raylib, because you can get the width of your screen surface wherever you are in your code, no matter what scope, because in here I have defined my screen width and height variables inside the game class, and it would be very difficult, well, a little bit difficult to access them from the player class, from within the player class. So the easiest way is to use this Raylib function. Self.position.x will be set to get screen width. Let's see what happens. You see, it may be partially constrained, but not completely. In order to do that, we have to account for the width of the basket. And we add plus self.texture.width. And at the same time, we subtract it in here from the screen width, minus self.texture.width. Okay. Now, move to the right, and ta-da, we stop there. We can't cross the border. Same to the left. Okay. So that's our basic movement functionality we need. It obviously could use some tweaking, but we can do that later on. Anyway, here's the input code, but yeah, it's a little bit clumsy. We can do it more concise. It still very much does the job, and it is readable, but we can do it a little bit more concise. I'll comment it out and do it like so. Self.direction.x is equal to, and now we check for, we need a positive value that is being returned, is key down, key D, and a negative value for going left is key down, key A. Let's see if it works. And yes, it does. Just fine. And why is that? That's easy to... It's pretty simple, because these statements here return Boolean values, right? So in most programming languages, true or false values can also be expressed as ones and zeros, and that is exactly what's happening in here. If I push down the D key, it's going to return a 1. If I release it, it's going to be 0. And on this side, if I push down A, it's going to be negative, because we flagged it in here with this little minus in here. It's going to be negative, so we move, our movement direction goes to the left. If I release, both are going to be 0, so direction is going to be 0 and no movement at all. Okay, so let's take a look. Is there something I have accidentally missed? Okay, one more thing. Down here, before we close the window, it's also considered good practice to remove all our textures or images we've loaded from memory. So for example, our BG texture that we have loaded into memory earlier, if we don't need it, then we unload it using the unload command. Unload texture, self.bg texture resized. So I think In this little game, it doesn't matter that much, but if you make a really big game with several levels or loading screens even, right? Something that really uses a lot of memory, then you would want to unload textures and assets whenever you see fit, right? In order to keep performance as good as possible. Okay, so that's it for now. See you in the next video, where we will cover the actual gameplay and the other gameplay object, like the apple we are going to catch, game over state, and everything else. So I hope you enjoyed, and yeah, have a good one. Bye bye for now.